Alright, let's look at the homework 4.2, 4.3, problem number 15. Alright, so let's use Gauss-Jordan elimination to solve the following system of linear equations. Alright, so I'll turn this into a matrix. So you have 5, 25, negative 15, and right hand side is 15. And 4, 20, negative 12, and the right hand side is 12. Alright, so let's do that. Alright, so what we want to do is first we want to turn this leftmost non-zero element into 1. Alright, so we can achieve this by just take row 1 and divide everyone through by 5. Alright, so let's go ahead and do that. So it's going to give us this matrix. 5 divided by 5 is 1. 25 divided by 5 would be 5. Negative 15 divided by 5 is negative 3. And 15 divided by 5 is positive 3. Alright, then we didn't do anything, so I'm going to just keep 4, 20, negative 12, and 12. Right, and actually before I do that, maybe I should simplify this a little bit to make our lives easier. And I noticed that the second row is everyone is a multiple of 4. So I'm going to actually go ahead and divide the row 2 by 4, right? Just so that we don't have to deal with big numbers. Alright, 4 divided by 4 is 1, 20 divided by 4 is 5, and a negative 12 divided by 4 is negative 3, and 12 divided by 4 is 3. Alright, so we got that. We have leftmost non-zero element is 1, so that's the leftmost 1. So we have to make sure that everyone else has to be 0. So this guy, we want that to be 0. Alright, we can achieve this by taking row 1, multiply by the negative number you want to get rid of, so it's negative 1, and add it to row 2. Alright, that will become our new row 2. So let's look at that. Alright, then you see that, let's see, nothing is changed in row 1, so I'm just going to write those down. Alright, then you multiply 1 by negative 1, add it to positive 1 is 0. 5 times negative 1, negative 5, added to positive 5 is 0. Negative 3 times negative 1 is positive 3, added to negative 3 is 0. And 3 times negative 1 is negative 3, added to positive 3 is 0. Alright, so we got the 0 row, and I guess that's all we can do. So this is already reduced. So what we need to do is we just have to turn the first row back into an equation. So this is going to correspond to x1 plus 5x2 and minus 3x3 is equal to 3. Right? And I would like to isolate x1, so I'm going to subtract 5x2 and also add 3x3. So which gives us x1 is equal to, you have 3 and minus 5x2 plus 3x3. Alright. So you can see that there are a couple of free variables, right? So you can say here there's x2 is going to be free variable, and x3 is going to be a free variable, right? So let's see if we can come up with the answer. I have to look at the form. All right, so it looks like there. Okay, if you look at the part C, so we're looking for doing that. And x2 is S and x3 is T. So we have to put So x2 is s, and this guy is t. All right. So you can see that x1 is going to be 3 minus 5s plus 3t. All right. So let's type it in. All right. So we have a 3 right here. All right. You have a 3 minus 5s. And then I forgot the plus 3t. Alright, so plus 3t. Alright, so that's the answer. So let's check the answer. Alright, got that. Alright, that's it. I hope that this was clear.